Hello, this is Maths with Lemon, and in this topic we will see the Lotka Volterra equations, which are basically equations that they interpret predator-prey models. Let's see this exercise to understand it better. In the predator-prey model given by the following equations, let P be the population of the predators and Q the populations of the prey. All population values are measured in thousands of individuals and time is measured in years. So I have two differential equations, P and Q, and they ask me first the first question. Find the two equilibrium points for the populations. Now I know that to have an equilibrium point, I must have the derivatives should be 0. So if I'll take the first derivative, it means that Q minus 2 times P is equal with 0. From here I have two outcomes. Either Q minus 2 should be 0, which means Q should be 2, or P should be 0. So basically now I have these two values. Let me see what happens when Q is equal with 0. Now with 2. Now I'll go to my second differential equation, dq over dt, which I want also to be 0. So basically it means that 1 minus P times Q should be 0. Now when Q is 2 here, if I will substitute my Q by 2 here the expression says something times 2 is 0. So basically Q is not 0, so 1 minus P should be 0, which means P should be 1. So when Q is 2, P should be 1. I'll do also the same for the other value. When P equals with 0, let me see what will happen in my equation. 1 minus P times Q is 0. So if P is 0, Q, it means Q should be 0. So the two equilibrium points is one, let's say it's PQ, it's 1.2, and the other one equilibrium point is 0.0. Now let me go to the second question. Use the equations to explain what would happen to the population of the prey if the predators were absent, so meaning P is equal with 0. From the first one, P is 0, so basically the derivative will be 0. From the second one, I will get though what? 1 minus P times Q, so basic over dt. So basically dt is equal, this is 0, so basically this one is Q. Now I have to solve the differential equation. I will use separable variables. So basically dq over Q should be equal with dt. I'll integrate. So L and Q should be equal T plus C. So now it will become Q equals e to the power of T plus C. So Q equals, let's say that this is E T times EC. So basically I will say that e to the power of C is equal with A times e to the power of T. to explain, it says, the exercise. So basically I see what? That my population will exponentially grow. And let me see the next question, which says, use the equation to explain what will happen to the population of the predators if the prey were absent, Q. If Q is 0 now here, then I will use my first equation, dp over dt equals, this is 0, so basically it will be minus 2p. And let me again separate my variables, equals to dt. Let me now integrate both parts, so it's going to be minus 1 over 2 ln p equals t. This is going to be ln p minus 1 over 2 equals with t plus c. So p minus 1 over 2 is equal to e to the power of t plus c. So p is going to be, sorry, I will solve it with a different way. Uh, 1 over p to the power of 1 over 2 is equal et plus c. P 1 over 2 is going to be what? 1 over e to the t plus c. So p is going to be 1 over e t plus c to the power of 2. So here, since it's in the denominator, this is a rational, it's a rational function. Basically it will look like that. So basically I see what will happen with my population of the predators will exponentially decay. We can use many methods to solve this. I mean, I used a little bit more complicated, but you know, you could understand that this one, if I'll put it, let me make a small here, p equals 1 over e 2t plus 2c, if I'll make the multiplication, and if I'll put it e to the power of 2c, which is equal e minus 2t, and if this is b, I can call it b. So you see it's exponential decay.